Alright, today we're looking at Pythagoras' theorem. So this theorem, you've heard it many times before, so I won't talk too much about it, but I'll quickly go over where the theorem, the idea of this comes from. So it comes from when we have a right angle triangle, and obviously triangle has three sides. And what's special about the three sides is that if you take this side, just say it's A long, and make a little square out of it, so this square is, the area of this square is A times A squared. And then we have this bigger one here. Let's say this is C. And the area of this is going to be C squared because C times C. And lastly, let's call this B. And the area of this is going to be B squared because B times B. Now, the idea is that when it's a right angle triangle, and this is what we do, if we make three squares with it, it always turns out that the area of the bigger side is equal to area of the two smaller sides added together. So that's where this area of the smaller two sides come from, equaling the area of the larger side. That is the idea of Pythag. So using this idea, we can actually find the missing length of right angle triangles. So for example, this one. Now, only thing you need to be really careful of, the shorter sides don't matter whether this is A or this is A, and obviously the other one being B. They're interchangeable, so you can make this B, make this A, or the other way around. However, C does need to be the longest side of the triangle at all times. So for you to tell which one's the longest, when it's not as obvious, this one is pretty obvious, you look for the right angle, it will have a right angle, and draw an arrow going sort of the opposite direction of the right angle. And this side, the opposite side of the right angle, is always going to be the longest side. And the name for the longest side is hypotenuse. So this is our hypotenuse. This is the longest side. And currently we don't know the length, so we call it C. So the longest side is always this squared plus this squared. And then here, I think the best thing for us to do in year 11 general is to put this in your CAS, solve for C, and then you're going to get your C right away. You don't need to do all of the algebra work to get there. And then it says round to 2 decimal place, and make sure you try this out on your CAS, you know how to do it, and hopefully this is the length that you've got for this one. Alright. I think a challenging part of this skill would be applying this in a 3D setting. So you'll need to be able to visualize what you're looking at. So let's look at this one together. So there's a cube here, which is a 3D shape, and has a side length of 5. So because it's a cube, cubes made up of squares, squares have equal side lengths. So every side length on this cube are all 5. So that's going to be helpful to us. And first we're asked to find AC. So the length AC, you can see, is here. And because we're in Pythag, you can imagine we're trying to look for a right angle triangle. Now this base over here, it has 4 right angles like that because it's a square. And if we look at AC here, it's the diagonal of the base. So if we take that and these two sides, so I'll just redraw this triangle sort of here, and I've drawn it poorly because you want roughly the same length. So these are 5s, as you can see, and the right angle is here, and this is A, this is C, this is B. So I've just redrawn it there. That means we can use this triangle to find AC. So the missing bit here, which is the hypotenuse, let's call it C. Actually, let's call it X because there's too many C's in here. So X squared will have to be 5 squared plus 5 squared. Again, put in the CAS, use the solve function to solve for X. And in this case, it's going to be 7 7.07 centimeters. Alright, so the first one's done. Second one, we're asked to find AD. Now, AD is a bit harder to visualize. So AD sort of goes across the 3D shape in there. And again, we're trying to find like a right angle triangle somewhere. And then if we just draw AC there and then AD there, you can see there's like a right angle triangle there, 3D shape one. And we know the length of AC now, which is 7.07. And we know this length over here, it has to be 5 because it's a cube. So then we have another right angle triangle like that, and 7.07, and it's 5 here, and we're missing this bit here. Let's call it y this time. So again, then we have y squared equaling 5 squared plus 7.07 squared. Again, use the CAS use the CAS to solve for this. And putting it into the CAS, oh my god, I'm pressing everything. You should get 8.66 centimeters.